and welcome to Discovery at Home. My name is Jillian and I'm a science educator at the Discovery Center. I'm so excited to be coming to you live today so you can continue to learn things and have lots of fun with science. Now today is all about boats, and while we're waiting for a few more people to join us, let's talk about boats. The weather's starting to get nicer, boating season is right around the corner, and as an employee at the Discovery Center, I know we often see lots of really large boats right outside in our harbor. One big example are those cruise ships that carry lots of passengers and lots of cargo. How does something that big float? So that's something we'll tackle today to get you learning more about floating and sinking through boats. I want you to think while we're waiting about the boats you've seen around you. Think about their shapes, their sizes, and the things they're designed for. I can think about a few pretty different examples like a single-person kayak. Think about its slender design compared to a really big boat that would need to carry more than one person or even cargo. If you get thinking through those lines, that'll help you while we get creating later on today. These different boat designs all are for different purposes. Some might need to move really fast. Some might move a little slower and need to be a little bit more sturdier so that they can carry cargo. All important considerations for today's workshop. So today, our workshop, Buoyant Boats, is all about creating a boat that can hold as much weight as possible while remaining afloat. And it's okay if our boats sink today because that will show us just the limit of capacity they can carry. We'll learn the science behind floating and then take a little bit of a break so you can complete your crafty experiment at home. Make sure you tune back in after you've produced that boat so we can try them out together and evaluate the results of your amazing feats of engineering. Now, before I hand it over to Adam to discuss the science that you will need to make your boat, I have a quick experiment for you. I'm not going to explain how all of this works because I want to see if you can explain it using the science you'll learn today. For my experiment, I have two pop cans here, a can of diet sugar-free cola and a can of regular Coca-Cola with all of its 39 grams of sugar included. Both cans have the same volume of pop at about 355 milliliters. We can ignore the air and the aluminum because for both cans, that volume is going to be the same. I'm going to place them in my tub of water here, and viewers at home, it's your turn to be good scientists, make a hypothesis or a prediction. What do you think is going to happen with my cans? Will they both sink, or will they both float? Will one float and one sink? I'll count down for you so you can make your prediction, and I'll release the cans into the water in 5, 4, 3, 2, 1. Here they go. Let's see the results. So I'll let my water settle down a little bit, but you may notice that our regular can here has sunk to the bottom, while our diet can is floating in the water. Now, why do you think that happened? If you're not sure, that's okay. I actually have a hint on my table for you, and the science you'll hear from Adam in just a moment will hopefully help you figure that out. Now, over to Adam to learn more about some boats.
Thanks, Jill. Hi, everybody. My name's Adam, and today's workshop, Buoyant Boats, is about using available materials to create a boat that can hold as much weight as possible while still remaining afloat. In order to help you visualize and plan what you're going to produce, let's talk about some science around buoyancy and boats. What does it mean to float or sink? We can think of floating and sinking as a physical interaction between a solid object, like a boat, and a fluid, like water. A fluid can also float or sink in another fluid, say like oil on water or helium in air. But let's back up a sec. What do I mean by a fluid? Fluids are substances that do not have fixed shapes and can flow easily. They can be a liquid, like this water here on my table, flowing easily, and taking on a new shape instead of the cylindrical beaker. Now we're getting the conical Erlenmeyer. And they can also be gases, like all the air around us, that I can take into my lungs, and they fill my lungs up. Density is one of the properties shared by solids and fluids. How dense an object is depends on how much space it takes up, which is its volume, compared to how much matter it has, which is its mass. All matter, including both solid objects and fluids, are made up of particles. I have two materials here made of different types of particles, some very light ones and some heavier ones. They're taking up the same volume, but this one's much heavier, much denser. You can think of density as how much matter is packed into a given space. If a lot of matter is packed into a small space, the object or fluid will be more dense. If a small amount of matter is spread out over a large space, then the object or fluid will be less dense. Water as a fluid has a density. If something is more dense than water, it will sink. If something is less dense than water, it will float. So let's see a comparison. Using my materials from before, my light material floats in the water, but my heavy material sinks to the bottom. Large boats that we might see around different parts of our province have hulls made of dense steel. So how do boats float if the material they're made from has a higher density than water? You can predict whether an object like a boat will sink or float by thinking about water displacement. Displacement means pushed out of the way. I'm going to show you something to help illustrate that. I'm going to fill up my 100 ml grad cylinder to, let's say, 80 mils to be safe. So check that, yep, good. And now I have an irregular object that I'm going to drop inside. And watch this line. Do you see the level of the fluid rising as the solid goes inside? And now we're up to 93 milliliters, suggesting there was 13 milliliters of volume in that bolt, which would be about 13 cubic centimeters. So you can use that displacement to measure the volume of a weird shaped object like the screws and the bolts on that piece of metal. If the weight of the object is more than the weight of the volume of water that is being displaced, the water can't hold it and it will sink, like our denser marble did. If the weight of the object is less than the weight of the volume of water that is being displaced, it can balance itself by floating on top, like our ping pong ball did. I'm going to tidy my workspace a bit for you to make my next point. I'm going to get all of my fluid back in my nice large beaker. There we go. Earl of Myers, done its job. Grad cylinder. And let's get these guys out of the way too. The amount of water that is displaced depends on the boat's volume, how much space it takes up. Understanding how much water is displaced is important, as the weight of the displaced water is equal to the upward force that holds the boat up, which is the buoyant force. The examples I've showed you so far have been of different materials. So I want to make this very, very clear for you, using the same material to build something that floats and sinks by changing its shape and therefore its volume. This is a bit of clay that I've already rolled out, so it's nice and flat. As it is, it will sink because it's heavy. But why don't we increase the volume? I'm going to pinch these ends in and make kind of a cup shape. And even though the same amount of clay is used, now this overall shape I've made also includes a bunch of air, which is nice and light compared to the water. So now this composite material made of clay and air is much less dense and can float on the water. If I take this and ball it back up, it is going to sink again. Now that we've talked about some science to help you visualize what you're going to produce, let's consider some materials and designs to help you continue planning. You will be producing a functional boat using materials you find. By functional, I mean your boat will need to float and carry a load without sinking. Once your boat is made, you will need to add other material to see how much weight it can hold. While making your plan, keep in mind the shape and volume of your design and think about the material properties. By that I mean things like how strong is the material, or how will the material interact with water? What other properties do you think might be important? Now, you don't need to do this part, but I like the idea of trying to use more than one material to produce your boat. Do you think you should combine different materials to make your boat? What would be the benefit of using, say, cardboard and plastic and tinfoil? I have various things laid out that I was able to find. This is only to give you an idea though. We'd love to see you come up with different materials and designs. In addition to having the materials to produce your boat, you'll need some type of weights to increase the mass to see how much it can carry before it sinks. This could be small change, rocks, or marbles like I used earlier. Pretty much something that's dense, that you can add gradually, so like bit by bit, and that won't be damaged by the water. Finally, you'll also need a place for your boat to float. This could be a large bowl of water, a sink, or a bathtub. If I were to use my beaker, one of the nice things about this is the straight walls. So if you don't have volume marks on your container and you have straight walls, you should be able to use a ruler to see how much water is displaced. That should now be everything that you need in order to make your plan. Now that I'm starting to think about trying out boats, I'm going to clean up my workspace, get rid of these materials. And I'll pull out just what we need for the next stage. Once you have produced a boat that floats, begin adding weight to see how much your boat can hold before it sinks. Try out your boat to see if there are changes you can make to your design so your boat can carry even more weight. Think about what modifications would allow your boat to carry more weight and be a better cargo ship. Modify your new design and evaluate your results. You can try boats one at a time or try 2 different boats at once using 2 different materials and see which one works better. Once you're done with all of that, if you want to keep thinking about buoyancy, fluids, density, and boat design, here's a few things you can consider. Your boat was made for freshwater. What considerations would you need to make if designing your boat for saltwater? Will the density of salt water be different? What if our seas were made of another fluid, like vegetable oil? What would you have to do in that case? Similarly, we now know that Saturn's largest moon, Titan, has hydrocarbon lakes composed of liquid methane and ethane. If you're going to create a robot boat as a probe to explore Titan's lakes, what would you have to consider in your design and planning? Well, I'll wrap things up by saying be creative with your boat and remember to share what you've built with us by clicking on the links in the description. We can't wait to see what you come up with. Now I'll let you float back on over to Jill.
Thanks for those helpful tips, Adam. That's some useful science to help us make our boats. Viewers at home, now that you learned about density and buoyancy, were you able to figure out my pop can experiment? If you didn't, I'll help you out. But first, let's do it again just in case you missed it, so you can keep wrapping your brain around it if you need a few more minutes to try and figure it out. I've got my can of diet pop and my can of regular sugary pop. I'm going to place them both into the water and see what happens. Remember, make a prediction if you didn't see this before. Is one going to float? One going to sink? Are they both going to float or both going to sink? Here we go. 5, 4, 3, 2, 1. All right, we'll let the water settle and have a look. My regular can of soda has made its way to the bottom. It has sunk in the water, but the diet can here is happily floating closer to the surface. Now, the reason one can floats and the other sinks is all based on density. Like Adam said, the density of something is equal to its mass divided by its volume. For this experiment, we use 2 cans of the exact same volume. We can ignore the air and the aluminum and just think about the liquid at its 355 milliliters. Now, it's the same amount of pop in each, but something must have changed. And we can check it out. We know that with mass and volume, that gives us density. Density is all about helping us float or sink. We know that that's very important to consider. So let's look. We know its volume at 355 mils. Let's check the mass by weighing the cans and see what we can figure out. All right, we'll start with our diet can here. And we're coming in at a mass of around 367 grams. All right. Our other can, our regular pop, is a mass of 385 grams. So our regular is a lot heavier. And that's because of the sweetener. We know that this has lots of sugar at 39 grams, whereas our artificial sweetener is much lighter. So because we have a larger mass divided by the same density, that means our item with the larger mass, or sorry, by the same volume, our larger mass is going to give us a larger density. And this means that it's sinking because that density is greater than the density of water. The downward pull from gravity is going to be a bit stronger than that buoyant force pushing back up from the water, and so my can sinks. The opposite is true for my diet soda. We've got a density that is a little bit less than that of water, and it's able to float. That buoyant force pushing up from the water is greater than the gravity pulling it down, so our can happily bobs along in the water without sinking. So speaking of floating, it's now time for you to get crafty and create a boat that floats. Have fun, try your best to make a boat that can hold as much weight as possible. While you're creating, don't forget to share your work with us on Flipgrid, Facebook, and Twitter using the links in the description below or by directly visiting our Discovery at Home webpage. If you have questions, you can always reach out using that Ask a Question button on our Discovery at Home page or by posting your question on our social media pages. I'll be here to help you all along as you're building, as well as our team of educators working from home. Make sure you tune back in at 11 a.m. so we can try out our creations together. I'll have a boat to test out and see the limit before it sinks. I can't wait to see your boats. Hello and welcome back. If you didn't tune in earlier, my name is Jillian, and today we created boats to carry weight. If you're tuning in late and want to make a boat, you can find the learning guide on our Discovery at Home webpage. You can also rewind the video now to watch a bit of the background science to help you build your boat. So now it's time to see what you, the viewer, sent in. You were crafty, you made some pretty unique creations, and it's time for us to have a look at what you've got for us. Let's have a look at our first viewer here. We've got a foil boat that was sent in by Japna. All right, Japna, this looks great. She's tested it out in a pan of water at home, and we can have a look next at how much weight she was actually able to carry. So with our sunken treasure, it looks like Japna's boat could hold 18 loonies before sinking. And that's a pretty simple design with just aluminum foil. It's pretty amazing that your boat was quite strong and could carry so many loonies. Great job, Japna. Let's see what our next viewer sent in. This boat is by Emily. She's also used aluminum foil, but she's changed things a little bit by adding some other structures in there. So we've got some plastic plant pots to see how that helps even out the weight. Let's check out the video. Looking good so far. It's floating. Looks like that plastic has helped, and it's also given you an area to add lots of weight in. She's adding some weight. Oh. Awesome job. So it looks a little tippy, but I bet when she adds this other glass, that's going to help balance things out a bit better. Looks fantastic. Oh, she's adding more weight. Oh. That's all right, Emily. Great job trying out your boat. See if you can modify that design to help you add even more weight. Can you spread the weight out differently? Could you use different materials to make your boat or different materials to test with? All right, let's check out our next design. This one was sent in by RJ, and RJ sent in a few different designs to show how materials interact with our boat and with the water differently. The first one uses some waxy candles and some bits of egg carton, it looks like. So it's floating with the candles, but notice that the egg cartons kind of did a sink. They got to soak up some water, they got a little bit denser, and they sank. But by adding other items, as RJ's tried here, he's added items that contain air, which is giving us a lower density and is allowing that to float on top of the water. Awesome job. Our next boat is sent in by Henry, and this boat was made out of clay. Let's see how Henry's testing went.
Okay.
Looks great. It's floating. You've added some Legos there.
And a bit more clay to weigh it. And a bit more clay. And a bit more. Oops.
Still floating. plus a Lego guy.
Oh no, it sunk.
Uh-huh. It held quite a lot.
But the Lego man saved himself.
Awesome job, Henry. It looks like your Lego man survived the capsize. Great job adding lots of weight to your boat. Our next one, I'm going to give this a name because Nicholas sent in a few different designs and he was looking for some name inspiration. The first design, I don't really have a crafty name for, but the second one you've added some pontoons to, which you'll see in a moment. I'll call that the Crafty Catamaran. Hope you like the new name.
Okay, so I'm gonna have my test. Well, first of all, it's my first test. I'm gonna do this, which is I'm gonna be adding these on my second, some 2 extra bottles on the side here on my second test. Well, at least it floats. At least it. No. If you guys can't really see it, I'm gonna start off with a marble or two. 1 marble. Marbles. 3, 4, 5, 6. These are 6 small marbles. I'm going to go on to the second level of marbles. Medium marble. 2 medium marbles. Medium marbles, 4 medium marbles. Medium marbles, 6 medium marbles. Now for the ultimate weight. Level 3 marble. No, I can't hold the level 3 marble. Oh, that's test 1. That's test 1. Now, you'll want to see the second video for test 2. So yeah, bye. Well, actually, I'm going to pause the video and then do test 2 in a second. Okay, we're back for test 2. So, my boat's a little better. That's what my boat looks like now. Get you guys at the right angle. I hope you guys can see it a little well. But there it is. We're going to test the big marble this time. Oh, we can hold a big marble. Now we're going on the medium marbles. 1, 2, 3, 4. I don't have a name for this. Just every time people, if you guys have an idea, chat back. So I'd really like to see what you guys come up with. I have 0 clue what I should do for a name. So that's 3, 4, 5 marbles, 6. Well, 6 small marbles and a big marble. 7, 8, 9, 10, 11. That's all my big marbles, and I have a humongous case of them right here. So, they're going on small marbles. Here's 3 smaller marbles. Another 3. Another 3. So that's 2, 4, 6, 8, 10, 12, 15, 16, 17.
All right. Wonderful job, everybody. I love what you've sent in. Your submissions are wonderful. Nicholas, I must add, those pontoons that you've added at the end were a really unique way of helping spread out the weight on your boat and also give it a bit more buoyancy by adding some air-filled chambers. Awesome job. Now, we're almost ready to try testing out our creations with some weight. I've got a boat here that I built on the break, but let's first talk about how we'll evaluate our results. First, you want to choose what you're going to add for weight. So I've got some nice rocks. Deciding what you want to add for weight will be a good way to help you frame how you're going to get your boat floating, because you might need to spread your weight out different ways. Now, let's pause for a second here. If you haven't built your boat yet and you're tuning in late and you want to get some inspiration and learn the background science, you can always rewind the video, watch it over, and then come back to us testing our boats at the end. All right, so as I have my boat here, first step is to, 1, pick my weight, 2, make sure it floats. I tried this earlier, and I'll show you what happens. Notice I have some rocks already in there. My boat design is pretty skinny and pointy, and it's super buoyant, but it's not very balanced. It's actually quite tippy. So the first step is make sure your boat floats. And if it's too tippy, or maybe it's too heavy, too dense, that it's sitting too low in the water. In my case, I need a little bit of added weight to balance it out. Give it some ballast, and we can get it to hopefully float nicely. All right, so I've got my weight spread out. We could see that that definitely affected the boat's ability to float, that tippiness. So let's think about the factors that will affect it carrying weight. The size of the boat itself, the bottom, whether it's flat, whether it's pointy, all of those things can make a difference. The materials you made it out of as well also make a difference. Is it sinking? Are the materials too dense, for example? So once you've decided, yes, your boat floats, or have made some modifications because it didn't, and that's okay, it's time to test out. I'm going to see how many of these beach stones that I can add into my boat before it sinks. But as good scientists, we should first make a prediction. I'm going to add my stones one by one. I already have 4 in there. And my boat's doing pretty good. It didn't sink very far in the water line. So I'm going to guess that maybe I can get at least 15 stones. So it's your turn. Make a prediction based on what materials you're using and how well your boat is doing on its own. And we'll see how it does. So we've got 4. I'm going to just keep adding until I either run out of stones or it sinks. We'll see. 5, 6, 7, 8, 9, 10. Notice it is getting lower in the water. We are displacing more and more water. We're adding a lot more weight. Our boat is becoming more dense, and it's starting to sink, but it's still floating. So we'll keep going. That was 10, 11, 12, 13. And notice how I'm adding the weight too. I'm not adding it all in one spot. I'm spreading it out to see if I can help my boat do a better job at floating. If I made it really heavy on one end, what do you think would happen to my boat? Test it out with yours if you'd like. All right, I think we're at 12, 13, 14, 15. So we've made it past my prediction point. Let's keep going. I'm almost going to run out of rocks here. 16, 17, 18. That's getting pretty low in the front end. 19, 20. Should we add the can? Let's see. Oh, so my can has lowered it a little bit in the water line, but I do have lots of air space in here, giving it a little bit of help as well. So I haven't added too much mass. I bet I could probably get 5 more stones in there before it really does sink. Okay, so now that my ship has almost sunk, it's time for me to say goodbye to you, but to remind you, keep doing modifications. I'm going to do a few changes to my boat to see if I can make it a little more sturdy so that I don't have to add extra weight to get it to prevent it from tipping. I encourage you, keep trying different designs, keep innovating. The limit is your imagination. My name's Jillian. I'm here from the Discovery Center reminding you to stay curious.